think focal molography is a really nice label-free technology compared to some of the other technologies I've worked with before, such as SPR, in that I think that it's very easy in terms of the sample preparation, and also it doesn't take long for the sensor to stabilize, and so we can really do fast experiments. And I also like that it's quite modular. We can change the temperature, we can change the flow rate, and also the fact that we can do it in flow versus static, where in some experiments we don't want to do things in flow, or maybe working with some very low sample volume that we want to just pipette it on the surface. And I think the fact that you can have these open versus closed systems also make it very useful for us.
I very much like the flexibility of the focal molography platform. It allows you to assess binding parameters in normal buffers, but also in complex media. So we are currently exploring binding in human serum and also in cell culture media. Currently, we also explore the ability of focal molography to quantitatively assess biomarkers in cell culture. This is of high advantage because by this approach we don't need to have separate technologies to, for example, measure proteins on cell surfaces and secreted proteins, but we can all measure them within one chip in real time.
The molography instrument has a relatively small footprint. It's a tabletop instrument, and it was quite straightforward to integrate it into a normal biophysical laboratory workflow. So right now we are using the instrument in our cell culture facility and try to investigate the kinetics of cancer cell adhesion on molograms, displaying adhesion-inducing peptide motifs, for example the RGD motif.
So another thing I really like about the current focal molography setup is that we can pre-program all of the experimental protocols, and then we can let it run, and we can go upstairs and do remote monitoring, which really expands the way in which we can do the experiments. We can have discussions with colleagues while we're actually running the measurement, and that's something that we really enjoy.
Big upside of focal molography is the ability to have a very high multiplexing. Up to 54 molograms can be read in parallel, which allows you to have a high degree of multiplexing, for example, if you want to read out several biomarkers in parallel from the same sample.
And I really like about the instrument that it gives a tremendous flexibility in sample handling, because due to the molographic readout principle, basically all of the optics can be placed underneath the sensing units, and all of the liquid handling can be placed on top of the sensors. So it gives the possibility to integrate the instrument with an auto-sampler for high throughput screening applications, but with a pipetting robot, the integration is also given, it's there. So right now we are focusing on cellular applications, and an open cuvette design was much more easier for us. So we are using a 4-channel and a 1-channel open cuvette, and we are very much looking forward to receive an incubator module which would be integrated on top of these open cuvette designs.